What's up, guys? Coach Tucker here. Hope you're having a good day. Hope school's going well for you. We're going to work some problems here from the vertex, quadratic vertex form. So it is a very useful form for quadratics. Think about the forms for lines, slope-intercept form, point-slope form, or standard form. They all have their uses. Obviously, slope-intercept form is the most widely used because of the information it has in it. The vertex form is super important for two pieces of information it gives us. One, it tells us the vertex. If you remember, the vertex is the highest or the lowest point of the parabola. And it also tells us what A is. And A is going to tell, A is what's multiplying times the whole quadratic. It's what determines how wide or narrow the parabola is. So it's actually pretty useful. So, warm up, quadratics and vertex form. What is the vertex of the function? So, first off, go back, watch that video. It will help. I am going to give a quick rundown of what vertex form is. So the formula for vertex form is, here we go, is f of x is equal to a times x minus h squared plus k. And the vertex is h and k. Ooh, we made that work, didn't we? You know what? Let's just make that k look a little better. There we go. So that is the vertex. So if you remember before I left, I talked about different things inside of arguments or parentheses. A lot of times you go with the opposite of the signs. It's negative in here. We want it to be negative, so h becomes a positive. So we want this to be a negative in order for h to be a positive, okay? So that's the vertex form of a quadratic. So there it is right there. That is the vertex form. And so when we're looking here, we have 3 times x minus 2 squared plus 4 is f of x. So what is the vertex? Well, because this is a minus, that's good. H becomes positive, so that's a positive 2. And then we do trust the symbol on the outside, and that is something that's been pretty standard. It will be standard for you as you keep going through some more algebra. So it's a positive 4 for the y. So there we go. So there's our vertex, 2, 4. So 2, 4, okay? Let's do another one. Here we go, yeah. So we'll write this down. I'm going to write this down because I want to go down to the graph in a minute. So 2 times x minus 3 squared minus 8 is g of x. Okay. What is the vertex of this function? And then write one of the function's zeros. Either one is accepted, and then graph the function. So we're going to stop there, I think. We need to go down. Okay. So what's the questions again? Vertex, 0, and then graph. Okay. So remember those questions because I'm actually going to go down here to the graph, okay? Because we're going to need the whole graph on this one, okay? So let's stop here. And let's pull out our sketch pad. So again, I'm going to write the function over here. The function was, no, let's put it right here. G of x is equal to 2 times x minus 3 squared minus 8. Boy, I hope I wrote that right. Here we go. So there's our function. So the first thing was the vertex. Well, again, this is just a read. Since this is a minus sign here, okay, it's not showing up good on the screen, but it's showing up on mine. Since this is a minus sign here, that's what we want. So h is a positive. So over here, we write 3, comma, and then here, a is negative. So we have to take the sign that it is on the outside. So there's our vertex, okay? So now zeros. When are the zeros? Well, it's when it hits the x-axis, right? It's when it's hitting the x-axis here. That means when is y0. So we're going to set this thing equal to 0, and we're just going to solve, okay? So we now have 0 equals 2 times x minus 3 squared minus 8. So we can solve this using the square roots that we did in the last video. So we'll add 8 over. So I'm not going to do every single step here because we're going to run out of room if I do. Divide by 2 to get your 4. So 4 equals x minus 3 squared. Take the square to both sides. You get plus or minus 2 is equal to x minus 3. So 3 plus or minus 2 is equal to x. So x equals 3 minus 2 is 1. 3 plus 2 is 5. So those are the two zeros. But if you go back up here, it said give a 0. And it did that. Well, you don't write both x's. You only need one of the x's. So just pick one. So we'll pick one. Now, I'm going to tell you one way you can find the y value. And I'm going to tell you the smart way to find it, okay? So one way you can find the y value for when x is 1 is you can go back up here and plug in 1 for your x, okay? Plug in 1 for x and multiply everything out, right? Now let me tell you the smarter way. 1 and 5 are your zeros, right? It's where the graph crosses the x-axis. What is the y value at the x-axis? There it is. That's the reason why we did all of that. So, 0. So either one of these answers would have been accepted for that problem, okay? So remember that. Let me write this down real quickly. So the vertex is 3 comma negative 8. A 0, we'll put 1 0 there for it. Okay. Now, last thing, it asks us to graph. So if we're going to graph this, let's actually do this in a different color, just so it stands out, okay? So the first thing we're going to graph is the vertex. So 3 comma negative 8, right there. We graph our two zeros when it's 1, 5. And then here's our parabola. And I am going to try to graph this thing. But get ready, it's going to look terrible. Oh my gosh, it looks terrible. This looks terrible. I say it looks terrible. Like, okay, so the strokes, like the actual like writing on the tablet is actually kind of fun. That's the whole reason why I did it, I'll be honest with you. Like, it's super cool how pressure sensitive it is. Like, that's me barely doing it, and then that's me really getting into it. I don't know, there's something cool about that. But there's the parabola. So when we graph this, we'll bring this bad boy there. Bring that guy down, okay? So let's go and type our answers in. So the vertex is 3, negative 8. Write 1 over the zeros, 0. And then graph the function. Graph its vertex first at 3, negative 8. The other one, put the 0 at 5, and voila. So we're good there. And the reason why the computer's moving slow is I'm actually processing the last video I made while doing this one. So it is what it is. Graph quadratics in vertex form. So we just did it, actually. So that was actually really cool while we did that last problem now. That's 8 minutes long now, so 8-minute long video. But do the same thing. Find your vertex first. Check. Actually, no, we're going to do this one differently. Let's do this one differently. Let's pull it up. Pull it up. Let me write this down. 3, negative 3 times x plus 1 squared plus 5 is what f of x. Okay. I'm going to show you a faster way sometimes to graph this. Let me show you another way. I got all kinds of ways. Good to know one way, better to know two, right? Bet y'all are tired. I bet you guys are glad y'all not having to hear that anymore. So it was f of x is equal to negative 3 times x plus 3 squared plus 5. Okay, so first things first, find your vertex. So the vertex is a super easy read. Since it's a positive sign that's opposite, that's supposed to be a 3, by the way. Go with it. So it's negative 3, positive 5. Now, this is where I would suggest you try something different. This is it. So, if you were to make a t-chart here, x and y, at negative 3, you know y is 5. Well, think about the way parabolas work. They bend off each other. right? But the vertex is always in the middle. So instead of just going to a random thing and picking something, why not pick one of the numbers close to the vertex, right beside it? So if the vertex here is negative 3, 5, right here. By the way, I know it's going to open downward because A is negative. If A is less than 0, it opens downward. If A is greater than 0, it opens upward. If A is equal to 0, see if you can figure out what happens if A is 0. I'm not going to tell you. I'll tell you in another video later, okay? See if you can figure out why. But, so it's opening downward. Why not pick negative 2 or negative 4? Because you know it's going to be really close to it. So it gives you an easier graph to draw, okay? Now, the one thing you're going to see some people do is say, well, pick both of them. You can. And if you pick both of them, you're good. They better give you the same y. Because it's a parabola. They're going to be the same. I generally don't. I'm a bad person. I'm going to pick negative 2. Okay? So if I plug in negative 2 here, I get f of x is equal to negative 3 times negative 2 plus 3 squared plus 5. That's negative 3 times 1 squared plus 5. 1 squared is 1. 1 times 3 is negative 3 plus 5 is, that's terrible, that is equal to 2, right? So when x is negative 2, y is 2. So when x is negative 2, y is 2. And if you plug in negative 4, you should have got that right there. You should have got 2 as well. Okay? Okay. So let's go graph it now. It was negative 3, 5. It was 2 negative right there. Did I do something wrong? Yep. I copied it wrong. I sure did. That sucks. Well, let's do that one in real quickly. I copied it right in my notebook, and I copied it wrong on here. Bah. Bah. Well, that other problem would have been correct if that was it. So let's real quickly do this one instead. The vertex, it's positive, so it's negative 1, 5. So negative 1, 5. Hey, look here, you know what's cool about this? Watch this. When you plug in negative 2 there, plus 1. Negative 2 plus 1 is 1 squared. 1 squared is 1 times negative 3 plus 5. It's actually going to go right back here again. It's just going to look like that right there. It's just right beside it. So literally my vertex, I just miscopied it. That's all. So I miscopied the x one. Bam. So if, pull up Sketchpad one more time. If this had been a 3 here, then that other one would have been your graph that we graphed earlier. But because this is a 1, the vertex is negative 1, 5, because it's always opposite sign of the inside here, okay? Opposite sign. So then it's negative 1, 5 is your vertex. And then from here, plug in either, you could have plugged in 0. 0 is probably what I would have plugged in because it would have been super easy. But you get the same thing either way, so. Hopefully that makes sense. If not, I can make another video later explaining that. But you guys are pretty smart. You probably understand where I screwed up and why I screwed up. So let's do one more. Let's do a word problem. We're getting close to 15 minutes now. So we'll do this one word problem. Actually, you know what? No, let's not do a word problem. Let's make word problems our own thing. So I'll probably do a couple word problems in the next video. So check out the next video if you want to see how to work this problem. Thanks.